to all present here. Thanks for the opportunity, Srini, and thanks to all of you for being here. I hope I'm clear. Voice is clear. Uh, Currently, the challenges, as I said, I would be introducing to the lint, why lint. So, in that perspective, currently, when we see the challenges in the chip design flow, one of them, the very first thing that comes to mind is the cost of the SOC, and it is anywhere, between 1 million to 100 million, depending on the complexity and the technology used and things like that. Also, there are sophisticated languages being used, which is mostly System Verilog and, of course, the VHDL. We all work on a global team, like a pyramid structure, and there is various time zones as we are seeing it today also. And the major contributor for this, one of the challenges where we see is the engineering team cost, and of course the EDA tools. We all know that, and then the IPs being purchased. So what's the solution there then? So we say that it's open source to the rescue. Why? Because it's scalable. Also, it's easy to adopt. When we say that, what we mean is that it's not just that we have a one EDA tool which is just given to all customers or to all different kinds of design or technology and say that here is what it is. But in open source, what we are saying is we build as we go. It's build. There's an option to contribute back where you can contribute to this whole open source thing that we are working on. It promotes the brand and also it attracts a lot of talent. So there is a continuous improvement in the overall ecosystem. And it's a proven thing to be in the CI/CD flow, integration practices like SVN, GitHub, and things like that. And then potentially it's vast, and we have a diversified skill force here. We're talking about that in the open source model. So the open source landscape, if you see the EDA landscape for, as you see this here, we have the synthesis for synthesis, we have USYS, we have Verilator and Icarus for simulation with GHDL and NVC. For the debug, we have GTK Wave and Surfer. The parsers are Variable and SLang, which is System Verilog Lang. And also for the lint side, we have the Verilator and the Variable. We also have PySLint and SVCK. For the backend, it's the Open Road, the package manager or the flow automation, and the code generators, we have RAL and VHDL. So here's a picture on the right-hand side, which says the same thing. So moving on. For the RTL lint open source, it's very popular. We all are aware, we have been using it for a long time. What it checks is the naming guidelines, the coding style checks, the synthesis checks, and of course the DFT checks. So many teams even integrate this into the CI/CD flows, and it's a good source, open source alternative becoming available as of today. So low risk is a popular, so this is a low risk guidelines plus the open source. So what we are trying to convey here is the low risk is a popular open source company. It's an SOC company. It provides the Open Titanic SOC. They have published a set of rules for the RTL code. So we are working on linting those rules with the open source tools, mainly the Verilator, Variable, and more. So implementing this low risk rules using open source tools. So the rule says, on the left-hand side, we are talking about the both Variable and Verilator has been tried. It is, we're talking about the advantages. It is easy to integrate with the CI/CD. The custom policy setup easy in Variable. New issue is opened with Verilator for use model. It's also a Verilator config and potential candidate for prime time adoption. Now, the low risk rule, if you see on the right hand side, the bit vectors and pack arrays must be little endian. So in the variable pack dimensions, the rule is pack dimensions range ordering. In Verilator is ASC range. Similarly, we see declare all signals We don't have it's none in variable, while in very later it is implicit. For the functions rules, it is explicit function lifetime and implicit static. And name your generated blocks. So it's in variable, it's generate label, whereas we don't see it in very later. So while to lint the test bench code, so we talked about the RTL. So here we are talking about test bench code to find the bugs early. Of course, there is a shift left, which we say is to save the time and cost. The opportunities in verification we see would be the system Verilog test bench, the UVM code base, assertions, acceleration, emulation, and formal verification. Open source test bench lint, it's a new paradigm. It's old and proven concept. It is being used open source. The code analysis approach is changing. It provides flexibility and customization option. So one of the things, build your own linter, which Ajita would be talking soon. And then the APIs allow custom applications. Few good parsers or tools for this would be variable C++B based rules. The SVLint, it's Rust based, it's custom plugin. The PySlint, which is a Python base, works on top of slang and PySlang. So here is the PySlint approach, and it's built on top of PySlang, Python System Verilog language. It's the Python-based rules. We have a minimalistic rules as case studies. We would be talking about it soon, and most of this is available in our GitHub. It helps customers to build it on top. We in fact help customers to build it on top on their own rules, and which is proprietary also. We also customize the existing rules to the condition of the thing that customers would like us to do it. There's a newer analysis of the tools and apps. It's definitely not intended as a traditional EDA product. That is what we want to highlight here. Rather, it's an open room for innovation. We would like to invite people here, and there is a qualitative and a quantitative metrics which is unique in lint or static analysis here. So the value proposition for PySlint. So here is what we see, the various categories. If you see the compatibility, we have about 14 rules. On the debug, it's 8. The functionality, we have about 10. In the naming style, 11. In reusability, 5. Performance, 3. And very later compat, it's 2. That's what the graph on the left-hand side shows. Here, as we go team, how we can help. We deploy open source design and verification flows. We develop custom plugins and the rules. We enable the workforce creation at scale. We also enable CI/CD flows and the port the IPs to open source platform. So these are some of the things where, as we go as a team, we can help and come into picture. The traction and roadmap. So this is established solid framework for the test bench linting. As you see, we have presented many papers and in many conferences. We have Verification Future 2023 or conference, FPGA World, State of Open Conference, DVCon India, and many others. So this is an established framework for the test bench linting. We have the sample rules, which is free open source in the GitHub. The roadmap that we are proposing, we are talking about as SVA for formal verification, SVALint and UVM lint, and also the simulator compatibility rule decks. That's it. Thanks a lot once again. And here we have Srinivasan Venkatramanan, who's our CTO, CEO, and his phone number is in this slide. Yeah. Thank you. Thanks all. Any questions?